Welcome everybody, and it's good to see that we have a very good turnout for this presentation. My name is Westerman. I run the product management function at Vordel. I'm relatively new to Vordel. This is about my 6th week, and I'm here to talk about some cloud security use cases. I'm actually standing in for our CTO, Chief Technical Officer, Mark O'Neill. Some of you may be familiar with Mark. He's been very active blogging on the various security blog sites, and do his presentation justice. If you know Mark personally, you know he's Irish, so I won't be trying to impersonate his soft Irish brogue at all. So getting started quickly, who is Vordel? You may not have heard of us. We provide an application gateway. We deploy that in scenarios of an XML gateway, an SOA gateway, increasingly an API management gateway, or internally for security integration across the back end. We've been in business for over 12 years, and we're a proven leader. So we have a very solid product. Forrester rates us a leader in the SOA application gateway technology, and we have strategic partnerships with Oracle and Ericsson. If any of you are Oracle customers, you might be aware of the Oracle Enterprise Gateway. That's actually an OEM of Vordel technology, and Oracle selected us for that capability after 2 years of very difficult due diligence. We have a global customer base. Many large organizations use us across all markets, and some very major government agencies. And we have global delivery capabilities. So while you may not have heard of us, we do have a proven technology and a proven install base. This gives you an example of some of the enterprises and government organizations that are actually leveraging technology. How's the sound coming across? Okay. Test. Take this off to avoid the feedback. Is this better? Okay, and so this gives you an overview of some of the type of organizations. You can see that they are very large organizations, and this just shows that Vordel, we're used in mission-critical deployments. So what is the Vordel Application Gateway? It's basically a governance, a control point. So as you're exposing your applications and your capabilities out onto the internet to partners, some of those could be trusted partners, or in the case of API management, to very partners which are new, you don't know, you need to apply governance, whether that's security, whether that's monitoring, whether that's auditing, the internal control policies. And we provide this application gateway via configuration-based policies. It's very easy to implement this governance control point. It's a very rich feature set, which we will explore. So let's move on to the cloud security use cases. What we've done in this presentation is selected 3 examples from the Vordel customer base who are using the application gateway in a cloud computing scenario. And there are 3 different scenarios, because when we categorize cloud computing as either software as a service, infrastructure as a service, or platform as a service. And that's a very nice categorization, because it really identifies how that organization is using cloud. And so our first scenario is that we're going to be looking at software as a service. In this case, it's an organization which is actually going to be doing single sign-on to Google applications. And with this software as a service, the experience is very much as though you were using a desktop application, but there's no software installed. You're accessing the application functionality entirely via the web browser. The second use case we'll look at is infrastructure as a service. How can we manage the provisioning of virtual machines in the cloud via, in this case, an organization that's using a web portal to do that provisioning, which is again supported by the application gateway. And then the final case, we'll be looking at an organization that's exposing their business as a platform. They've created a set of APIs which they host upon the gateway, and those gateway APIs are being used by Facebook at the moment, but other partners in the future to provide, in this case, the provisioning of virtual gift cards. So basically, they are making their business a platform via exposing APIs to the cloud. So jumping right in, let's have a look at the software as a service example. In this case, single sign-on to Google applications. The organization, company here is Education Management Corporation out of Phoenix. And basically, they are an education provider. They have over 100 private colleges throughout the United States. For example, the Art Institute of San Francisco, the Art Institute of Phoenix. And besides actually managing the colleges themselves, they also provide the IT infrastructure. And they made the decision that they wanted to outsource all of their email, rather than going around for every single college, having to install Microsoft Exchange, support it, and set up all the student accounts. They wanted to outsource that to Google, leverage the cloud for the email provision. And so when they provide their students with a college email address, it's actually Google Applications, Google Gmail in the back, which is fulfilling that. But from the college perspective, from the student perspective, that's totally transparent. Their experience is though they're interacting with the college portal. Now, while that provides a lot of benefits to EDMC in terms of reduced IT costs, there's an important technology consideration of achieving the single sign-on. And so here we have our student. He's off to college, and therefore what the college provides is a college portal. And so the student will log in to that portal, and this is really the college homepage. This is where the student can get access to all information about the college, the curriculum, the specific course details, and maybe also upcoming events. But they can also access their college email from this, and they do that just by clicking on the link. Now, the important requirement here was that the student was not forced to sign on again onto Google Apps. From their point of view, they've signed on into the college portal, and they need to automatically go into Google. And so when they click that link, it takes them over to Google. They can see their inbox, they can read their email, they can send email, and do everything you can do in a web-based email browser. So from the student experience, it's very simple. They click on the link, they're there, it's a transparent, seamless experience. But that's really just the tip of the iceberg, because underneath the covers, there's a lot of technology happening in order to achieve that single sign-on. And this diagram illustrates how it's done. Basically what's happening to achieve this single sign-on is a whole set of message exchanges, a message choreography, in order to assert to Google that the student has been authenticated. And so in this case, Google is using SAML. They haven't created any proprietary technology. It's all open standards. And so when the college wants to do the single sign-on, they send the request to Google. Google will send back a request, a SAML request, basically asking asking the college, in this case the identity provider, to assert that they've authenticated the student. And then they will send that SAML response back up to Google, acknowledging that they've authenticated that student and asserting their identity. Now, as I mentioned, this is all based upon open standards. It's all well docked. You can go onto the Google Applications documentation website, and you can actually see this, and they provide very detailed instructions of actually how to implement this. So how did EDMC decide to implement it? Well, firstly is that, as we just discussed, the college portal is the identity provider. The first requirement is that you have to have some place where you establish the identity. And this is where the college portal, because this is where the student is logging in. And so what the college portal is going to do is assert to Google that they have authenticated and validated the identity using the SAML assertion. Now, what EDMC could have done was that they could have, implemented this entirely in, by writing code. But it's all well documented. They could have implemented it themselves. But they chose to use, a vendor product. In this case, they went to the market and selected Vordel to actually implement this single sign-on. So what is the gateway actually doing? Firstly, it's validating that the student has logged on. It validates their identity. And it does this by checking against Active Directory, because when the student logs into the portal, they update the Active Directory with their authentication status. And then based upon that, the gateway is actually constructing the SAML assertion and putting it in the response. And so here we can see, just an example of what that SAML assertion looks like. It's this, the block of text at the bottom. So the gateway is automatically generating that based upon the student's identity. And as you can see here, this is going back up in a REST call back into Google. It's all standards-based, and that's URL encoded and signed with a key that Google will provide. And so, as I mentioned, there is this key which the gateway is taking responsibility for. So what is this key? This key is issued by Google to organizations that want to do single sign-on. So any organization that wants to use Google Apps and single sign-on to those, Google will give this organization a specific key. Completely standards-based, it's an RSA or DSA private key, and that organization will actually use that to sign all the responses that they are sending up. And what that is doing is validating to Google, approving to Google that the organization sending the message, sending the request, is who they say they are, because that's the only organization with the key. And so this is vital to protect that API key. If that API key gets into the wrong hands, then other organizations can use that for bad purposes. Because basically, it's the key to the email of all the students. With that key, you can access all the email without the password. So it's vital to protect this. And this is going to be a reoccurring theme across all of the scenarios that we're going to have a look at, is the need to protect these cloud API keys. And it's really about the importance of API key management. Because if we contrast that with SSL key management, there's a lot of awareness within the security industry about the importance of managing SSL keys securely, of keeping them confidential, and the risks, for example, if they are compromised. In fact, there's a whole industry around, for example, protecting those using hardware security modules, for example. Unfortunately, protecting API keys has not reached that same level of awareness. We find that in many cases of API keys, because they're being more used by developers in their applications, which they are creating to connect to cloud-based applications, they're a lot more lax with their security. They tend to email them around. They tend to, for example, put them on the hard drives of the applications that are doing the single sign-on. And that's all, a risk, because if that key is discovered, then it can be used for mischief by other people or organizations. And so Vordel, or in particular our CTO, Mark O'Neill, there's a nice little picture of him here, has been doing a lot of evangelizing about the need for protecting your API keys. In particular, working with the Cloud Security Alliance, he's posted a number of blogs on this subject. And so I would certainly recommend you taking a look at this blog, because he describes the risks in detail and also some of the possible solutions. So just moving on, let's now have a look at the second scenario, which is the infrastructure as a service. And this is about managing, for example, cloud server instances, virtual instances up in the cloud. Now, just a little bit of history is infrastructure as a service really comes from the world of virtualization. Organizations have been using virtualization for a number of years now because of the benefits of managing virtual servers over physical servers. Really, infrastructure as a service is taking that a step further, because it's now providing a cloud infrastructure where organizations can basically request and manage virtual machines using a very simple configuration process and using a pay-as-you-go sort of model. Very much moving towards the concept of utility computing. So you as an organization don't have to go through all the bureaucracy of provisioning new machines, installing those, and bringing those up. So there's a lot of benefits, a lot of convenience by using an infrastructure as a service. In particular, in terms of configuring them, they tend to provide a lot of automated tools. So you can merely request the provisioning of a new machine, the type of the size of that machine, the power, compute resources, also aspects about the operating system and software. And the other aspect is it tends to come out of operational expenditure rather than capital expenditure, so it's easier from a budgeting perspective. And if we have a look in the marketplace, there's two big players. Amazon EC2 with their elastic compute offering, they're so big, you can regard them as their own camp in the market, and they're based upon the Zen virtualization layer. And the other camp is based upon VMware's vCloud. VMware themselves don't actually produce or provide a public cloud infrastructure as a service offering. What they do, they are providing vCloud, which is really the platform for building that. And then they work with partners, for example, Terremark, which is now owned by Verizon, and they take the vCloud infrastructure and will actually build a public cloud offering. So how does this actually work? So basically, all of this provisioning and configuring these machines is done via APIs. So regardless of the vendor, they provide a set of APIs so that you can create these machines, you can start them, you can stop them, you can reboot them, you can terminate them. And surprisingly, in order to access these APIs, you need an API key, which is really authenticating you to the cloud service vendor that you have the privilege to perform these operations. And so here we can see an example of some developers just spinning up machines. They have access to the keys, they can do anything they want, provision new compute resources. So while that's very powerful, there's also risk. Because all of these infrastructure as a service, virtual machines, they cost money. You are paying as you are using them. And in many cases, the billing is tied to corporate credit cards. And there are many scenarios where you actually start up a new machine, you use it, but you forget to shut it down, it's still running, and then you actually end up with a nasty surprise when your credit card bill comes about all the compute resources. And so what we're seeing at Vordel is a need for a layer of governance in order to access these resources. And it's not just about security. Yes, there is the security aspects of that you want to control who does what. You might have different, for example, roles. You might have managers which you want to give permission so that they can actually do the creation of the virtual machines, they can actually terminate them, and maybe just give permission to the developers to stop and start them. So there are various security policies that you may want to enforce. You also might want to have an audit trail. Especially from a financial perspective, have an audit trail of who's doing what with the virtual machines, and then relating that back to your operational expenditure budgets. Or policy-based alerting. It's a Friday evening, a bunch of machines which were started in the day haven't been shut down. They're going to run over the weekend. You want to do some alerting so that they can be turned off, and so you're not billed for those. And again, it all comes back to this management of the cloud. And the final point is interesting as well, because while all the vendors, all the cloud vendors provide performance monitoring, you as the consuming organization may also want to have your own performance monitoring of the infrastructure as a service provider to make sure that they're living up to the SLA agreements. And so this is a pain point that we at Vordel are running into in a number of organizations. And what we're seeing is a trend to create a provisioning portal. So, and this is a Vordel customer, Infosys in India, the large Indian SI developer. They've got a large number of developers, and obviously the cloud is a very powerful paradigm for them. But rather than give the developers the keys directly, what they've done is created an internal portal. I've heard it described as a click-to-compute style of portal, where the developers access everything via this portal. So they can request compute resources via the portal directly. They can manage those compute resources via the portal. And this provides the central point of governance, because here you can validate who the developer is, you can manage the API keys, you've secured those, you're not distributing those across the development team. You can keep an audit trail. You can also monitor the performance. What's the speed of provisioning? What's the uptime that you're getting? What's the response time that you're achieving? Is the cloud vendor meeting your SLA agreements with them? And another interesting aspect about using this portal, it sort of decouples you from the actual vendors. Because as we saw earlier, there are multiple vendors. There's Amazon, there's Terramark, there's others like Rackspace. And so this really is a commoditized market. One Windows machine is much the same as another Windows machine. And so what the portal provides you with the mechanism to actually dynamically select which vendor you're going to use. You could do that based upon the type of hardware that you need. For example, the project, maybe the cost or other SLA agreements. And then the portal can dynamically select which vendor to use. And so thus you can play the vendors off between themselves. So how did Infosys actually implement this? Infosys implemented this, again, using the Vordel gateway. They could have implemented this themselves, it's all done via APIs, API keys. They could have created this code. But what they wanted to do was buy a solution off the market. And so in fronting their internal portal, they have a gateway. And basically the gateway is managing all those APIs for the portal from the cloud vendors. It takes responsibility for securing the API keys, so therefore they're protected. The gateway is hosting those in its search store rather than distributing those to the developers. We're monitoring all the service usage, and all of that usage data is logged. So thus you don't get any sort of billing surprises. You have this nice governance control point. And so now we'll have a look at the final use case, which is a little bit different from the other two. Because in the other two use cases, we were actually connecting up to the cloud. In the software as a service example, we were actually connecting to Google Apps to access our email. As the infrastructure as a service, we were connecting up to cloud virtual machine providers to provision new virtual servers. This one is different because we're actually connecting from the cloud. In this example, it's Facebook, but there will be other partners going forward. Now, you may not have heard of this company. It's called Black Hawk Network, but you're probably very familiar with their products. They are responsible for provisioning gift cards. You might see those if you walk around Walgreens or CVS. There's those little plastic gift cards like Home Depot or Chili's restaurant or iTunes. And then you buy those gift cards with a certain value. Now, when somebody goes off and uses those gift cards, there's value or money debited from that balance. And it's Black Hawk Network who are actually providing the back-end infrastructure to manage the value associated with those individual gift cards. However, increasingly, what they're finding is people are turning to what we call virtual gift cards. So rather than actually having the physical piece of plastic, you now actually get basically a gift code. And you can actually use this gift code in online applications, in online shopping carts. So in this case, we have, the Facebook marketplace. You can go onto that marketplace, you can select a gift card, virtual gift card, and you actually send that basically token to the recipient, and they can spend that value. In some cases, it's tied to a particular vendor, in this case, iTunes. In other cases, you could use that in shopping carts. And so all of this is provisioned on the back end by Black Hawk Network using a web API. By that I mean it's a REST web service called using HTTP. So in this case, it's Facebook Marketplace, which is actually invoking these REST web APIs. But going forward, Black Hawk will be adding other partners besides Facebook, and also providing mobile access. So people using their smartphones, can send gift cards. They can also check their balance. It's very interesting because what they've noticed is as they've rolled this capability outside the US is to some degree people are using these gift codes as a virtual form of currency. In some countries they don't like giving bonus money, so they're actually giving the gift cards loaded with significant value to their employees. In other cases they're actually using this as a form of currency. And so it's very important to actually authenticate the API usage so that we want to prevent unauthorized access to those APIs. Because if you have access, you can basically access the money associated with those gift cards. Another aspect which Black Hawk looked at is high performance. These are human-facing applications on a large scale. You can imagine many tens of thousands of users, Facebook at the moment, actually using these applications. So there's obviously a high performance requirement, in particular in terms of latency, so that you can service those human clients very efficiently. But then there's also the need to support spiking, scalability in terms of spikes, because they have a very cyclical nature. Many of these gifts are gifts of the last resort. So maybe, for example, just before a major holiday, you want to send some gifts just before Thanksgiving or Christmas. You haven't bought anything, stores are closed, you go online and you can give a gift code. So they actually find some very significant spikes within their business at certain times of the year. And they also wanted to use industry standards. While they wanted to make sure that their APIs are secure from an authentication purpose, they also wanted to make it very easy for potential partners to connect with them, because they're going to start to onboard other partners. They didn't want to actually require the client to write lots of code using proprietary security frameworks. They wanted to make it very easy. So they went out into the market and they looked at the Amazon Web Services, the query API Amazon provide for their web services platform. So while it's not an official standard from an organization like Oasis, it is actually very widely adopted, within the organizations. And what it is a security framework implemented by Amazon for their, Amazon APIs like S3 or SimpleDB, and it's all accessed via REST. So Black Hawk decided to implement Amazon Web Services. And again, how is this done? It all comes back to this key management. Because Black Hawk is issuing all partners, in this case Facebook, with a key. And all access to Black Hawk's APIs has to be signed with this key. And that sort of proves to Black Hawk two things. Firstly, it is the client sending this message, because only that client is supposed to have that key. So it proves to Black Hawk they are who they are, because they can generate the signature. And secondly, that the message hasn't been tampered with, because by signing the message with that key, it proves that the message hasn't been tampered with, en route. Because basically, Black Hawk will rerun the signature algorithm once they receive it. So again, it's important that the clients do not share this key. And if we have a look underneath the hood, how is this implemented? We can see, for example, some of the security aspects which the gateway will be checking for. We're looking for, in this case, is there a laser here? Yep, we can see this case we have the nonce, which stands for number 1. Basically, the gateway will be checking for this particular field to eliminate replay attacks, because that's a unique field identifier within the message. And the gateway will only allow a particular message through if it sees this, this particular nonce one time only. So that prevents, for example, a third party intercepting that message and trying to replay this request by resending the message, because the gateway will block it. You may ask, well, why don't they just change that nonce? Well, that's where the key is important, because when you generate the nonce, you have to sign it to prevent it being tampered with. And we can see the signing algorithm in this case, which the gateway will be checking for. And just having a quick look at the operational visibility provided by the gateway. Here we're now having a look at the real-time monitoring console of the gateway, and we can actually see, for example, the messages that are flowing through. We can see the past messages that are being let through, they're permitted. We can see blocked messages, which the gateway is stopping for some particular reason. Now, the advantage to an organization like Blackhawk of using a gateway rather than implementing this in code is because they actually get visibility. It's not a black box solution. So if one of their partners phones up and says, my messages are being blocked whenever I invoke your APIs, from a management perspective, they can actually go in and have a look at, well, where is that message being blocked? Why is it being blocked? And so they can easily fix that. And here we can get some insight into how that's achieved. Because in this particular case, the gateway is behaving as both the client and the server. And we can see when we look at it that the gateway is actually building up that message. It uses a set of building blocks called filters. In this case, adding HTTP headers, adding nonces, adding the timestamp. And likewise on the server side, it's using appropriate filters to, for example, parse that message, parse the nonce, parse the timestamp. And so if, for example, the message is being blocked because the nonce has been duplicated, it would indicate in the particular filter, the particular building block which failed, so the administrator can very easily go and fix that. And then just in terms of building these filters, it's a very easy to implement policy development environment, very configuration-based, graphical-based. You drag these filters and then you can create a hierarchy of policies which the gateway can implement. So one of the requirements that Blackhawk was looking at was very easy policy development so that they can respond to new partner requests or new requirements. And so with that, we draw us to a conclusion, the look at these three cloud security use cases. Signing on to Google Apps as part of the software as a service, which is a requirement that we see on a fairly regular basis about organizations who are adopting software as a service style of applications. In terms of the infrastructure as a management infrastructure as a service, management of virtual machines, we again see this on a very an increasing trend with large organizations who want to create a click-to-compute portal and manage the interaction with provisioning those against the cloud APIs. And then finally, with the platform as a service, increasingly businesses want to expose their platforms using APIs, and you need therefore the appropriate API management to manage those APIs. And so again, the reoccurring theme, which is probably the one takeaway I would recommend for you, is really think, if you are leveraging the cloud, really think about protecting your cloud APIs. Treat them at the same level as you treat your SSL keys. Take it out of the developer's hands. One of the goals of Blackhawk Network was they wanted to get the API keys out of the developers at both their end and also their partners, and give the management of the API keys to the security administrators. And so I'd certainly recommend reading Mark's blog. Just before I finish, I did want to mention another use case and scenario that we are starting to see. It's not used in any of the three examples, but it's also about protecting confidential data. Because increasingly organizations will be sending confidential data to cloud providers, in particular platforms and also infrastructure as a service. And the recommendation from the cloud service providers is encrypt this, for example, confidential data, or remove this confidential data, or redact it before you send it up. Now, that's a pretty invasive process. It's invasive because you have to build it into applications. It can also be a CPU-intensive process. And so what we're starting to see is interest in using a gateway in line with that cloud interaction to actually, on the fly, encrypt certain pieces of information as it's being sent up to the cloud, and then likewise as it's being retrieved from the cloud. Now, as gateways can have hardware acceleration for this encryption, it sort of addresses a lot of the performance issues. So we are starting to see interest in this scenario, and that sort of spans across all three of the use cases. And so my parting thought, quote from Darryl Plummer, and hopefully just by looking at these brief use cases, we've seen some of the benefits of putting a gateway, and whichever gateway that you choose, between your interaction with the cloud. By using a gateway between the cloud and yourself, you take a lot of the governance aspects, whether that's security, monitoring, visibility, out of your application and into more of a configuration-based governance control point. And so I would certainly ask you to think about that. And so with that, I'd like to thank you for your attendance, and I can take any questions. Okay, thank you. Oh, sorry. The question was, for people of organizations that are not using gateways, where do they see the API keys currently being placed? We see them a lot either in the development environments, developers just keeping them on their local machines and therefore just emailing them out between themselves. On the production machines, actually on the hard drives of the applications, which are doing the single sign-on. In some case, the developers might try and hide it in a particular place so that it's not obvious. But what we recommend is it shouldn't be in the developer's hands at all. It should be within the security infrastructure. But because developers now have to work directly with the API key in their applications, they're getting involved in those keys. So the question was for those organizations that decide to use a gateway where they didn't previously, do you see them removing the keys afterwards, after they've deployed it? No. I mean, the one example I can say is when I was speaking with Blackhawk is it's an interesting scenario. Is the gateway is involved in both the development side and the production side. So in effect, I mean, the way that the Blackhawk are doing it, when they issue you a key, they give that key to the developer, and that provides access to their sandbox environment so that they can test it. When they decide to onboard that developer, and the onboarding process is very interesting because it's not just a click of the button, there's a whole bunch of risk and legal paperwork that needs to be done. They don't reissue a new key. They just give that key authorization to the production systems. Exactly. And it also bleeds into, gets into the developer mindset is that the key API key is part of the security infrastructure, not part of the application code. And so my recommendation would be is even on the development side, use the gateway. or whichever gateway you select. One more. So they're just a standard slide deck, you know. So yes, these slides are okay. Yeah. Okay, so with that, again, I thank you for your attendance and enjoy the conference.